Okay, so I assume that you already watched this video tutorial mean over discrete random variable, right? I assume that you already watched this video tutorial. Now let's take a look at this problem, the practice mean expected of discrete random variable, just as previously mentioned. Since this problem is from the test bank, you may not be able to see this exact problem. Yes, but in a method, right? It's pretty much same, right? So let's take a look at this problem. Rodrigo plans to buy a pack of baseball cards until he gets the card of his favorite player, but he only has enough money to buy at most 3 packs. So suppose that each pack has 10% of chance of containing the card he wants, right? So basically this is a table, and x is a random variable, right? Which represent the number of packs of card he buys. So if you look at this probability that x being 1, right, is 10%, 0.10. And then the probability that he's going to buy 2 packs of card, right, the probability is 0.09 and etc. So this is a table. So this is what? This is the probability distribution table, right? Now, basically the problem asks for calculating the mean of x, random variable, right? So expected value of x. So so this is a notation for the mean, right? So let's take a look at this the equation, right, in detail. Okay, so we have a random variable of what? We have a random variable of x, right, which represent a number of packs, right? The packs of card that he buys, right? And so the random variable is okay. So and then so expected the value of random variable x, right? Expected the value of x. Also, this is another notation for is a mu, right? Mu, and then we put the variable name, random variable name x, right? So that's another notation for the expected value of x. So this is random variable. When you have a random variable x, you have x and then x, right? Okay, and then notation, and then the formula to find the expected value of x, or the mean x, right? So this signifies the mean. It's equal to sigma. The sigma is a sum, right? And if you look at the equation xi and pi, right? So if you look at the equation, that means xi and pi, as you can see. Okay. So what that really means, you know that sigma means what? Sum, right? And this, we can expand this formula as i's varies. So for example, typically it's this this I is equal to n all the way to n. So that means x1, p1, the p means the probability. Okay, x is a random variable value for the random variable, right? And then x2, p2, and then all the way to xn and pn, right? And another notation, this is like a bridge notation, but if you want to have a full notation, sigma, right, is I is equal to n, right? And then we have to say the xi, right, same thing, and then probability p, the probability when the random variable's value is equal to xi, right? So that means what? That means x1 times the probability that the random variable x is being what? x1, right? So you know that this value and this value is the same. And then plus x2p, x is equal to x2, right? And etc. And then we have xn multiplied by p, x is equal to xn, right? So go back to the table. We have what? X, random variable x is equal to, let me just write it down, number of pecks, and 1, 2, 3, and then probability that x is what? 0.01, 0.09, 0.81, right? Okay. Okay, so if you look at this table, if we use this formula, right, finding the expected value of random variable x or the mean of x, right, to find the number, the expected value of x, or the average number of packs that he buys, right, to find that value, so ex or the mu x, right, the mean number of packs that he buys. So it's, if I use this formula, it's equal to x1 is what? 1, right? So 1 times then the probability that the random variable is being, the value of the random variable being 1, right? Plus x2 is this value. So 2 multiply probability that it's x is equal to what? 2. And then we're going to use this, right? So 3 multiplied by x is equal to what? X is equal to 3, right? So if you look at this problem, 1, 1, 2, 2, 3, 3, and you know that this is from really here, right? Okay, so if you calculate this, you know that the probability that x being 1 is 0.10, so 0.1, and then being 2, the probability of x being 2 is 0.09, and this one is 0.8, right? So we can calculate this, right? And the answer is, as you can see, oops, hold on. The answer is what? 2.71. So that means on average, right, to get until like he need to buy about what? 2.71 packs, 2.71 of packs, right? 2.7 packs of card. Then he can get the card he wants on average, right? Of course, on an average. So he can buy, let's say, 1 pack, and then he can get the card he wants, or maybe he need to buy 3 or 4 or 5. But on average, he need to buy what? About 2.7. He need to buy 2.71 cards until he gets the card he wants. But of course, the limitation is he can only buy up to 3. So yeah, so number of cards he can buy varies from 1 to 3, right? But number of card he can buy, it's really from 1 to 3, right? But on average, he need to buy this many packs of card, right? Okay, so let me just end my lecture here.